let's start the jam. Video notes, here we go. Take a notebook out, let's start the show. Video notes. Video notes.
Hey, welcome everybody to this week's edition of Video Notes for Mr. Flugum's chemistry class. Today we're talking about density. All right, this is a really important topic, and we're going to take it a little deeper than you have gone before in maybe your physical science class. All right, just so you know, these notes will go on page 12 in your chemistry notebook, and they're due on Thursday. Let's go ahead and get started. All right, folks, well, density, right? We've talked about it. And it's basically a combination of mass and space. That's what it measures, right? And to kind of put it in like layperson terms, right? It's how much stuff is in a certain amount of space. Okay? This can be a relatively important measurement when we're talking about chemistry because it can identify the substance for us. All right? If we can get an accurate measure of density, we can get a pretty good guess of what that substance is. All right? Now keep in mind, density is mass over volume, right? And we wrote this down in our need to knows last week that generally density is measured in grams per centimeter cubed, right? Or grams per milliliter. Either one works, right? Just remember, a centimeter cubed is equal to a milliliter. So we need two measurements, right? First thing you need is the mass, so we're going to use a balance, right? So you need to find out how much stuff is there. And then we need to figure out the volume. Now there's really two ways to figure out the volume. Okay, one is displacement. All right, how much water or liquid does the object displace? Or there's kind of the dimensional way of doing it, right? So if something is a box or a cube, we can just do length times width times height. And you can do similar things if you have a cylinder or a sphere or even a pyramid where you can just easily use a mathematical equation along with accurate measurements to find the volume. Alright, so here's where the rubber meets the road, folks, the calculations. Okay, there's just some basic algebra involved here, but you need to kind of think it through and be able to do this, right? This is where the rubber meets the road. And we need to be able to use density for more than just saying, hey, here's a number, right? We need to be able to use density to figure out different things about substances, okay? In this case, we're going to try and find the volume, all right? Now we're given, as you can see, we have a pure gold necklace that has a density of 19.30 grams per milliliter, all right? Then it says, what would the volume of a 3-gram pure gold necklace be? So we've got two things, right? Now remember, density equals mass over volume, right? Well, we have the density, okay? And we have the mass. So we just need to be able to calculate the volume. So let's plug things in, right? Here we go. 19.30 grams per milliliter. And I really recommend that you put in your problems the units. You will thank yourself for that. It's important because units tell you what the answer is going to be. They cancel out, and if you don't know what the units are supposed to be, it makes it easy to figure out, okay? And you'll make less mistakes down the road. Really, it doesn't take any extra time, right? So we've got our density there, okay? That's going to be equal to our mass, which is 3.00 grams. And we want to know our volume, so we'll make that X, okay? Now essentially what we have here is a ratio, right? Because 19.3 grams per milliliter, we can just put that over 1. And all we do is simple, boy, you've probably been doing this for years, right? Simple cross multiply. Okay, so we got 19.30 grams per milliliter, okay, times X, Okay, and that's equal to 3 grams times 1, which is 3 grams. Okay, now simple, right? Solve for x, we divide. Okay, 19.30 grams per milliliter. Okay, same thing here, right? 19.30 grams per milliliter. Okay, so these cancel out here. We get x. Sorry, I'm going to move up here. Hope that's all right. And then here, if you look, we've got grams over grams. Those cancel out. So what are the units in our answer? Milliliters, right? So you just do a little bit of math. And 3 divided by 19.3. And I get this. 0.155 milliliters. And that's our answer right there. Alright, last one here, last example. You've got a rectangular block of copper that weighs 1,896 grams. The dimensions of the block are 8.4 centimeters by 5.5 by 4.6 centimeters. From this data, what is the density of copper? Well, simple, right? Density equals mass over volume. Well, right here we have the mass, okay? And it says it's a block, right? So we have the dimensions of the block. So we need to figure out length times width times height, right? So we'll do that, right? 8.4 centimeters times 5.5 centimeters times 4.6 centimeters. Okay? Do a little bit of math, and that is equal to 212.56 centimeters cubed. Okay? Remember to keep the units on there. Makes it a lot easier. So now we do this, right? We have our volume. So we just do this. Mass, 1896 divided by 212.56 centimeters cubed. Don't forget to put the grams on top. And do a little math. And you get this. 8.9 grams per centimeter cubed. Alright. Now this week, we'll be doing some things with density, including using this to analyze different substances and identify them. So being able to work with density and calculate it or calculate backwards from density is going to be very useful. Thanks for tuning in, folks, and I hope you have a great day.